Hi everyone, I'm Amitai Rotem. This is Randy, my colleague, and we're from the Windows Defender engineering team. If you're here to learn about Windows Defender, you are at the right theater. If you heard us talk previously, this is a repeat, so nothing new for you guys. I kind of want to start and talk about why we're here. Well, admittedly, we weren't great. We've been improving a lot in the past couple years. We want to show you what we've done, especially around cloud protection, using our big data. Just to get a kind of set of feel of the people here, how many of you using Windows Defender? Or in your company? What about SCEP, System Center Endpoint Protection? Okay, very few to none. Great. So hopefully by the end of this demo, more of you will go out and try us. We're also known as System Center Endpoint Protection, Microsoft Security Essentials, Forefront Endpoint Protection, OneCare. You might have heard all those. Same exact common anti-malware platform. And over the years, we've had like the different names for different. It's Windows Defender now. Whether you use it at home, like you said, in your company, Windows Defender. It takes a while until the brand comes out. So you might still see SCEP. You might see stuff. Windows Defender really is the name. So you might have heard a lot of keynotes over the past couple of days and talks about the big data that we have. I'll quickly recap it. We are on every endpoint pretty much by default, which means that we see a lot of computers. And if you're IT pros, it's awesome because you don't need to deploy anything. There's no anti-malware to deploy. You just need to configure. We are on most SKUs of Server, starting with Server 2016, optimized for Server as well. So it's not just yet another anti-malware running there. We also protect Microsoft online services like Bing, Skype, Office 365. And the cool thing about it is that we get a lot of telemetry back. So it's not just that we protect them. We can see malicious email campaigns that go through Office 365 for users that use a different anti-malware, learn from it, and then protect Windows Defender users. And obviously, we dog food it also at MSIT. Well, what do we do with all that data? How much data do we really have? Over 1 billion calls a day to our protection service. So that's every day, 1 billion unique calls into our protection service. Over a month, we see 1.2 billion unique devices. We have over 80 billion files that we have the metadata of. We have trillions of URLs indexed. And what that allows us is to see the ecosystem. And one thing that we see about the ecosystem is this. There's only a few hundred malware families, new malware families on a monthly cadence. That's about it. Not very impressive. You'll see those on like malware, websites, encyclopedias. But then each and every one of those keeps getting wrapped with AV evasion techniques. So literally hourly, right? They'll take that malware, they'll wrap it differently, the malware authors, and we'll see a unique file. And then even more so, they'll use command and control centers to kind of send you a malicious link. And behind the scenes, they might be reproducing new files every minute. Right? And so when you go to the link, you'll get something different than your coworker who got the exact same link. And what that means is that they infect most of their computers pretty fast. How many days do you think it takes for a malware basically kind of to run through its campaign to infect all the computers it's going to infect? You. Any guess? How many days? 2 weeks. I was actually pointing at you.
I was cheating.
You were cheating?
About 7 hours.
How did he cheat? How did he do that? Yes. You win a Surface Book. No. But, 30% of devices will see that malware within about 4 hours. Okay? After 7 hours, most of the computers will already seen it. After 20 hours, we're barely going to see that malware in the wild. That's it. That's the lifespan. And so after about 7 hours, that's when it really, that's it. It got it what it's going to get economically, and it's out. But signatures take longer. Even if you have the most advanced, and we hope we do, machine learning, we see a malware, we write automatic signatures, we go through quality control because we're publishing them out, and it's hard to backtrack, and we take them out. Well, your organization's only going to poll for new signatures twice a day, 3 times a day, 4 times a day. That still leaves many hours, and you want to beat them. So cloud is the way. That is kind of how we are going from reactive to real protection. And at this point, I'd like to let Randy show us a demo of how we do that in the wild.
Okay, so first off, it looked like there weren't a lot of Windows Defender or System Center Endpoint Protection users here. But let me ask this question. So for those of you, I presume most of you are running anti-malware on your endpoints, probably. How many of you run cloud protection if it's an option for your anti-malware? Not seeing a lot of hands. I see one. So just to set context on how cloud protection works, and specifically for Windows Defender, when you download a file or stick a USB drive in or save an attachment from mail your users, Windows Defender endpoint, the code running on the box, the anti-malware platform that Amitai was talking about, will scan the file, and if it has heuristics and different ways, signatures, traditional signatures of course, but also behavioral analysis that we do on the box. Most of the time we can figure out, is it clean, should it be allowed to run, is it malware, we'll block it. But there are cases where something looks suspicious, but the endpoint code doesn't have something telling it that it's a strong enough decision that we can go ahead and block it. So at that point, the client can call the cloud and send up information about the suspicious file that it's seeing. And most of the time, the cloud can take that information, apply machine learning models that have been trained on the back end against that huge volume of data that Amitai was mentioning, the billions of queries and trillions of URL reputation that we have, and make a decision. And that's the first demo I'll show you. So there's going to be kind of a two-part demo. And the second demo is really the case where that initial cloud query, that check from the client up to the cloud, and here's a packet of the information we were able to extract metadata about the file on the client. In the cases where the cloud is still not able to make a decision on that, it can go back to the client and ask, hey, send me in a copy of the file. I need to do deeper analysis on it. And that's really where we've made some major improvements in the anniversary update of Windows 10. So if you're running Windows 10 anniversary update, there's new capabilities in the client that lets us do some really neat things around the time it takes for the cloud to learn about new malware and start to block it. So let me show the first piece of this. So here I have two users on two different VMs. They've both been sent email from an attacker. I'm going to put on my attacker hat here in a second. And you can see I have a mail that says it's from Frederick in IT, important SVC host.exe update. I should install it. Well, that sounds good. IT sends me something. I don't really know Frederick, but let me go ahead and click that here in a minute. First though, putting on my attacker hat, I'm going to, I've sent out my mail to all this is how the campaign starts. I've emailed out the targeted attack mail to my victims. Hopefully, hey, I saw you at this conference. I talked to you here. Hopefully they think, oh, or in this case, I'm, from your IT department. Please install this update. And so now I've sent out that mail, but on the back end, on my command and control, I'm going to be periodically generating a new version of my malware to evade detection by anti-malware products. So what I've just done is run a script to detect or to create a new version of my malware to try and obfuscate it from anti-malware scanners. And just to show, I don't know, anybody use VirusTotal for looking up files? Yeah, so when I search for this particular file hash in VirusTotal, you see it's not found. It's definitely something that was just created right now. Okay, so now that I've uploaded the file to the command and control, let's take a look at what happens when our users go to click the link and download the file. So on the first user, I'm going to go ahead and turn off cloud protection. So I'm going to turn cloud protection off. Not recommended. Please don't do this if you're running Defender, because as you'll see, we get major protection benefits from having cloud protection on. And let's go ahead and download this file. And again, this is, go ahead and download it. This is going to get scanned by the Windows Defender client. If I had cloud protection on, I would be checking with the cloud. But right now, I'm just relying on the signatures and intelligence on the box. You can see Smart Screen doing its job, trying to protect me. Warning me that this looks like something I shouldn't run. I have to go through some hoops to run it anyway, but as we know, users will tend to just go ahead and click through and run things. And uh-oh, I have a little bit of a problem. Apparently my hard drive is being encrypted. Let me go ahead and switch to the second user that has cloud protection on. So I'm going to download the exact same file. Again, this is a link to the exact same file that we just generated. And we'll go ahead and download it. Again, it's going to get scanned by the engine, but this time we're going to call into the cloud and say, hey, do you know anything about this? And you can see the virus was detected, and I wasn't able to download the file. And we get the pop-up from Windows Defender. So let's talk a little bit about how were we able to do that detection. And before I forget, while I'm thinking about it, I'm going to go and protect this machine, turn cloud protection back on. And now this guy is protected through cloud protection as well. So I mentioned that in this case, this is a scenario where we don't actually even need the file to get uploaded into our backend and to be processed. We don't need to collect the sample in order to detect it. So how were we able to detect it? In this case, we have a rule, and this is the cloud kind of logic that's up in the backend that we use to detect that file. And so let me just walk through it real quick. So I have a set of file names that I'm looking for. So if the file is named like a common Windows component, so SVC host in this case, but it could have been Explorer, WinLogon, one of those. And the file is not signed. Or the file says it was signed by or the file was signed with a digital signature, but was not signed by Microsoft. And the classification was malware. And what this classification equals malware with a confidence of 85% or greater, this is a machine learning model that we have trained against all that huge amount of data on the back end. We basically run it to learn for specific malware families or specific types of attacks against all the known attacks and train so it can see and come up with a confidence score that says, hey, based on all of the malware in this particular family or all the malware we've ever seen, this looks like it's 85%. I have an 85% confidence that this is malware. So if you put all these things together in this cloud rule, unsigned Windows, file named like a Windows component, not signed, and classified with 85% confidence as malware, at that point on the cloud, we're confident enough, even just getting some information from the client that lets us make that determination, we can go ahead and block it. So as far as what goes into that machine learning, so part of what, when I say the Defender on the machine sends up metadata, it's extracting a bunch of information, attributes about the file, and sending that up. But it's not sending the whole file itself. It's a very lightweight call that gets sent up. So that's the first scenario. And again, this is the majority case. We don't need a copy of the file to get into our backend in order to be able to detect it. And we can really block this brand new malware on that patient 0 machine. So this is, again, the very first person running Windows Defender to encounter this newly crafted malware in the wild was able to be protected. As long as he had cloud protection on. So now I'm going to switch to the second case, the more rare case, but and this is where we've done some really interesting work in the anniversary update. So I have a second attack mail, and I'm going to once again generate a new malware on the back end. We'll show that it's not a file that's in VirusTotal. So again, just proving that this is not known malware. And I'm actually going to show that in our cloud backend as well. So this is our sample store. I'm just checking to see, hey, do we have this particular file by hash in our sample store? And you can see it's not there right now. And I'll come back to that and check again momentarily. So what we'll do is go back to this machine. And I'm going to go ahead and download this file. And this is our patient 0 for the sample upload case. And we'll go ahead and download it. Again, I have cloud protection on, so I'm checking with the cloud when I download it. Again, Smart Screen is going to try and do the right thing, but I'm going to run it anyway. And you can see it ran. The cloud did not know that it was malware, but asked for a copy of the sample. So when I go back now and recheck in that sample store, oops, let me do one other thing. You can see we now get some metadata about the file, and that shows us that it is now in our backend. And you can see also here, this is where our researchers go to look, that we also have now a bunch of data in the cloud about it. And what I want to highlight in particular is if we look at these two side by side, you can see, so on the blue, the PowerShell window, this time here, 1948:59, this is the time that the file was uploaded from the client and hit our backend. So this is when it hit storage and we got a copy of it. At that point, file processing kicks off, and we go and do deep scan. We throw this thing into a detonation chamber. We scan it with a bunch of tools. We extract all this information. This is like the deep kind of ripping it apart piece of the analysis process. And there we can then take all that data that we get and once again apply machine learning models in real time that have been trained on the back end, trained every few hours against all the continuously updating information we have. And you can see here that I do have a result from one of our machine learning classifiers, this ACBAFS classifier. And you can see it classified the file as malware with a 95% confidence. But what I really want to highlight is the time here, 1949.01. So let's see the time that it took 1948.59 here from when we first received the file to the point that the cloud actually had classified it as malware was about a second. So when I go to the next machine and download the same file, go ahead and download it. Again, exact same file. This is just the second person to go ahead and download it. It should get scanned and should get blocked by the cloud. But for some reason, I don't seem to be, tell you what, let me go back to the email. Well, it should have been classified and blocked. We've had some issues here at the conference connecting in. Let me try it not from the VM. Oops. Yeah, I'm going to just try it from my actual laptop and not the VM and see. Let me go ahead and, for some reason, it wasn't clicking the link. So let's go ahead and try it just from my laptop. I don't know why. Well, for some reason, my clipboard isn't getting this. All right. Oh, sorry. OK, so should have got blocked. Let me do a quick run through of what. Yeah, can you go back? What's that? Oh, yes. Actually, so this didn't work. I think it was a connectivity issue. We do have a, don't switch it yet. We do have a website where you can actually run through this exact same scenario. You can create a new file, check it, VirusTotal, all that good stuff, and then go to a second computer, download the file, and it should get blocked if you have a cloud connection to our cloud. And so we have in the, we have information on how to go do that. Come talk to us afterwards, and it's also in the information for our presentation. All right, now you can switch. Oh. Okay, so I want to quickly run through what happened in this scenario. So I generated the email. You saw me generate a new file backing that email. First user downloaded it, and this is where we send that metadata up to the cloud. And in the first case where you saw we blocked the file, or yeah, when we had the cloud protection, the first demo, we were able to block the file based on that metadata. That's where in the second case, when we did this evaluation, we came up with no verdict. And so this is where we didn't have a verdict, but it looks suspicious. We're going to go ahead and ask the machine to send up the file. So we request the file from the machine. It sends it up, and this is the thing that's new in, you saw right after it was downloaded, it appeared in our sample store. This is what's new in the anniversary update, is we're basically holding a lock on this file on the client until we get a confirmation that we've uploaded it into our cloud backend. In the past, what we would do is basically send these things through an asynchronous channel. We would let the malware run and then try and get the sample. And what would happen there is that the malware would often, by that point, our catch rate was very low because the malware has already, deleted itself and is off doing other things or obfuscating itself or otherwise getting in the way. So now we only let the file run once the user, we get the confirmation that it was uploaded to the cloud. And at that point, this automated file processing kicks off, and that's where you saw that we had that machine learning algorithm came back and said, this is 95% confident that it's malware. And from that point, the second user, and this is the part that didn't seem to work. So if, and this is where I think we had the failure, was that if I had been able to talk to the cloud you saw had the classification that was malware, should have responded that, hey, this is malware to the client, and it would have been blocked. So unfortunately, we seem to have some connectivity to the cloud issues there, but that's the scenario. So what I really want to highlight here is Amitai talked about, and we had the 7 hours that it takes malware to generally monetize their campaigns. And that's the space that, sort of anniversary update, that's kind of where we were fighting with the malware authors. They might have their campaign 5 hours. They're trying to infect as many machines as possible, get as many people to, pay the ransom or whatever before they, shut down shop and move on. And we're trying in this game of trying to get aware of that, generate signatures, get those out to the client. If their campaign is 5 hours, we're trying to get it there by 4 hours, that kind of thing. And what we've been able to do in the new anniversary update and with the new version of our cloud protection is really get to the point that we can, seconds, as you saw, after we become aware of a file, we can determine this malware and start protecting all the other users who query the cloud and ask about that. I think we're low on time. The only thing I wanted to highlight here is that we have this sort of virtuous cycle. As the more we learn and get all that data that Amitai talked about the more we can refine these machine learning models, retrain them as we learn what's malware, what's not malware. We can start to make much better decisions over time. And you can see that if you came to our longer talk with the protection scores and the test results and all that stuff, we can apply other things based on that data, like fuzzy hashing, so that we have other techniques we can use. Machine learning is one technique we use in the cloud and where we're investing very heavily, but there are lots of other things that we look at in the cloud, things like reputation. So, is this file being downloaded based on smart screen reputation, those kinds of things. We can put all those pieces together, and you saw the example rule where we had, different things that we were looking at. And then ultimately, this is a good way for us to make smarter decisions about when do we ask for a sample, when do we decide that we need to do a deeper analysis on something and get those in and then get that data, and then it just keeps getting better and better.
Yeah, thanks, Randy. So we'll just summarize by saying, like you said, we're getting better. We know we weren't there. If you look at the latest scores, you'll notice that we're constantly improving. Where we were almost at 0 a couple of years ago, we're actually very, very competitive. We ask you at the end of this session, look up that kind of block at first site, test site, try us in your own organizations, talk to us, wdcustomer@microsoft.com or on Twitter. If you try it out, it's not blocking what you think or it's not doing what you think, we really want to hear. And yeah, we'll stay around for some Q&A. Thanks.
Oh.
What?
Any questions?
Yeah, if we got the time here, then sure.
Yeah.
So, if you run as least privilege, is that going to make you less susceptible if they try to stop that upload to go to the cloud to be inspected?
Yeah, so
I would think that that's what they're going to try to do against this process.
So I think the short answer to that is yes. The longer is actually, if you noticed, Randy did this demo not on Edge, and he didn't use Office 365. And there's a reason. And the reason is that each protection technology is kind of another layer, right? Another wall in your defense. And so everything you can do, right? The user's a non-admin, that's protection. You're using Windows Defender Application Guard, that's great, right? So anything you can do, at some point, the first line of defense and the last line of defense would be your anti-malware. I hope
if I'd run that scenario in Edge with Windows Defender Application Guard, it would have been sandboxed, been running in a VM, it wouldn't have been able to do anything. So, definitely recommend, we're here talking about Defender, but there are so many other great technologies now with Device Guard, Application Guard, Credential Guard in Win 10 that you should definitely use those as those first layers, and then this should be the final layer if something gets through to try and block it. Any other questions? Yeah. And if you want to come, we'll hang out for a few minutes.
Yeah, we'll hang out
right
here.
Us.
Thanks.
Great, thanks.